Very good afternoon to Dr. Nordin, Director General of Angkasa, Prof. Patrick Collins, Mr. Nurul Rizwan Zakaria, President of Space Tourism Malaysian Chapter, Dr. Rosman Mat Aziz from Ministry of Education, Dr. Muhammad Slamat Madu from Malaysian Agriculture and Research Development Institute, MARDI, and all participants. On behalf of National Space Agency, Angkasa, I would like to thank you all for joining us today for the talk of Angkasa Talk titled From Microgravity to Orbital Flights. This is a joint effort program with Space Tourism Society Malaysian Chapter. I'm glad to announce that this session is on live streaming via Angkasa TV, YouTube, which can be accessed through our website or Facebook page. Okay, without further delay, now I would like to invite our Director General, Dr. Nordin Ahmad, to deliver the welcoming speech.
Thank you, Madam Chairperson. Very good afternoon, Professor Patrick Collins from University of Azabu in Japan. Mr. Nur Ridwan as the Space Tourism Society Malaysia Chapter. Dr. Rosman from Ministry of Education, and Dr. Salamat Madu from MARDI. Also to fellow members, invited guests, and everyone here. It's very much delighted for us to receive Professor Patrick Collins, who will brief us today, probably the things that we have been looking forward to, the latest technology in how to carry out microgravity experiments, in a cheap way, I hope. I have to make cheap slowly. Okay. And we also like to thank the Space Tourism Society Malaysia for able to co-organize with us. Thank you very much. Ladies and gentlemen, for your information, the government of Malaysia, through the National Space Agency Angkasa, has so far been involved in several microgravity experiments. Since probably you know the first astronauts program in 2007. Among others like the microbe in space, cell in space, protein in space, food in space, and some student experiments. So in continuation of the programs that we have carried out in 2007, there are also other few related microgravity programs like the parabolic flights, the protein crystallizations, Malaysian Space Seeds, Mars 500s, Tri-0G activity. I hope it's not so confusing to some of you, but some of these activities are still going on, and especially to the students, we have a few programs for them as well, and you may participate in the Tri-0G, okay, program every year, where your proposal can be carried out in ISS. Hopefully it will be carried out in suborbital flights. Okay. Anyway, one of the things that is being focused by the ministry, or mostly, is on innovation. So, so today we are very fortunate to have Professor Patrick Collins to brief on the current innovation, which is to trying to carry out a microgravity experiments in a more we call it valuable environment, which is the suborbital flights. Well, Prof will explain what's suborbital flights after this. So with the current initiatives, well, actually not current, have been carried out years ago, but I suppose that everybody are looking forward So Prof will basically, hopefully, I'm not giving you feeding you anything here, but I'm sure you are, since you are the expert in this area, hopefully you are able to enlighten us on this, what is basically suborbital flights, and as well how much it is different from other ways of doing microgravity. And the main thing is, what is the future? I mean, since there are a lot of works have been carried out, how long will are we going to wait for these suborbital flights to be realized by us, the community? So I think without further ado, I would like to wish all of you a fruitful discussion, and of course talk from our experts. And we at the National Space Agency would like to thank again Prof. Collins and the Space Tourism Society for making this possible. Thank you very much.
Thank you, Dr. Nordin. Now I would like to introduce our distinguished speaker, Prof. Patrick Collins. Prof. Patrick Collins is exceptionally well-known and respected expert in the field of space economics, space tourism, reusable launch vehicle, and space solar power. His expertise is the economics of energy supply from space. Prof. Collins is currently attached to Azabu University in Japan, and he is also a collaborating researcher at Institute of Space and Astronautical Science, ISAS. Now, I welcome Prof. Patrick Collins to deliver his talk titled From Microgravity to Orbital Flight. Prof, the floor is yours.
Thank you very much for the kind introduction, and thank you also very much for the invitation. It's a great pleasure to speak about this. I work at Azabu University, where I teach mainly economics and environmental economics. And although this is a major part of my research, I don't actually have that many opportunities to talk about this work, so I very much enjoy talking about it. And you know, it's often said that you shouldn't ask a researcher about their research, or they'll never stop talking. So please, after about an hour or so, just tell me, that's enough, that's enough. Well, I think you probably know that there are growing expectations that commercial approach is going to reduce the cost of space activities. There's been what they call something like a revolution inside NASA. You remember they had the space shuttle, which was a sort of reusable vehicle, but they were very expensive. And a large team inside NASA said, okay, we're going to build a follow-on to the space shuttle. And there was what they call a civil war inside NASA, where another gang said, no, if NASA does it, it will never get cheap. And we must make it cheaper to get to space, because it hasn't got any cheaper at all in 50 years. So the official American government policy was the follow-up for the space shuttle will be done by private companies. And there are a number of private companies now trying to develop such vehicles. And it's very difficult, and they don't have much money, and it's going to take quite a while. But they're determined to make it cheaper. And so that's a large part of what I'm going to talk about today. And partly my interest from an economic point of view is that this will then create many new industries and new employment. So just to jump straight in, NASA started Microgravity University. Now, it's not actually a university, unfortunately, but it's a program. Unfortunately, in very small letters at the bottom here, but it says Reduced Gravity Flight Opportunities Program. And they use this term, Microgravity University, to encourage really what the Director General was just saying. Anyone in America, particularly students and so on, are invited to propose, what would you do if we gave you some microgravity? You know, as if you were to fly on a parabolic flight in an airport or so on. And this is very popular with young people, you see. So that this is a program that's continuing. And I think it's also very promising for work in Malaysia, because it can be low cost. This is a picture, you know, people in microgravity, they're just floating. The good thing is you don't have to go to space to experience microgravity. This is inside an airplane. So. And if you fly an airplane, it's called a parabolic flight, you go up and down. About this point, you cut the engines, so the airplane just goes up and over here. You get about 20 seconds, 25 seconds of zero gravity. The pilot keeps the plane in the right direction, but inside, you just float about, you see. So there's no, in zero gravity, there's no up or down. And so this is how they provide. This is, as I said, just 20 or 30 seconds, 20, 25 seconds of zero gravity. And this is a person doing an experiment, This is just showing things float about, Everything floats during the zero gravity. And so the experiments are interesting as experiments, but they're also very popular with the young people because they go with the experiment. So they get to fly in zero gravity. And airplanes can get 20 or 30 seconds. But what was just said just now, suborbital flights is when you go up in an airplane, up in a rocket, and just go up and then come down again. To go to orbit, right here in orbit, you have to go 7.9 kilometers per second, 8 kilometers per second. This needs enormous energy to get to orbit. But to go up to about 100 kilometers and down again, you need only about 1 kilometer per second. And this is only about 2% as much energy as this. So that you fire the engines for about a minute, and then the rocket floats up and floats down again for about 3 or 4 minutes. So you can get 3 or 4 minutes of zero gravity. So you can do other experiments which you can't do in 20 seconds. So this is one of the services which we're hoping that companies are going to start providing quite soon. Now, people have been doing research on microgravity for several decades already, and unfortunately from the business point of view, there aren't actually yet many profitable products as a result of that. They found, all sorts of things that are interesting to physicists, but businessmen want to be able to make something that they can sell, and there aren't actually very many economically valuable ideas so far. But when the cost of traveling to orbit and back, getting to space, gets much lower cost, then of course these opportunities will be better because it'll be lower cost to use microgravity, and we'll be able to do more things in orbit. And so I and colleagues are more interested in this. The research up to now is very useful, but we're more interested in looking forward now, what is going to happen in the future. So this is what we're keen to prepare for coming opportunities. And one which I'm particularly recommending is what I call metal bubble engineering. You can make soap bubbles on the Earth. If you use a special method, you can make metal foam. This is a piece of metal foam. I've actually got a little piece of metal foam here made on the Earth. If you want to look at it, I can pass it around so you can look at it. But you can't make very big bubbles on the Earth, because if you think about it, you can try it yourself with some low temperature metal. If you blow some air into it, it makes a little bubble, but it soon collapses because the metal is heavy. If you want to pass that around. Yeah. And so it's used for some materials to strengthen materials and so on. But in zero gravity, one would be able to blow metal bubbles as big as a soap bubble, or as big as this room. You make a big blob of liquid metal and blow air into it. And so in future, I read about this when I was a student. I thought we would already be doing this. But you could, 2 particular products. One is you make a foam, see? So you could make a great foam beam, maybe a kilometer long, to make a large structure, which you can't make on the Earth. See? So it would be very lightweight and strong. And the other one is just large single bubbles, okay, which could be as big as a house or big as maybe a sports stadium, as a single bubble. And this, of course, is potentially, one has to have a little imagination, a very productive way of making lots of structured space stations in orbit. So that's the future, see? So it's got a very promising future. And we need to start, obviously, in a cheap way. And this we can start on a very simple way. So with the centimeters type things, we can use a low temperature metal. Do you know gallium? The metal gallium. It melts at 30 degrees. If you put it on your hand, it melts into a little pool of metal. And maybe the Air Force can do some zero gravity flights for us. So this is an example of a little piece of equipment. This could be inside a box about 50 centimeters square. We have a tank here with liquid metal, a little motor here to push the metal out of the nozzle here, and an air pump here, blowing hot air through. So you could blow a bubble here, and then cool it, you see, with cold air to make it solidify. And then we'd have some cameras watching the process, you see, to measure the size which it grows. And this would, you can easily see this is not a very complicated piece of equipment. It would be quite fun for students to develop this. And although we're starting with little bubbles like this, we've got this vision of where we're going to go, building gymnasiums in orbit. It's really a promising piece of work. So just to give some of the details, we need computer control. This is really the same, but it also needs to be quite robust, because in a jet plane, in the parabolic flight, there's some vibration. And for the research, you have to take an antiemetic, anti-travel sickness, because otherwise zero gravity and then 2 gravity, your stomach gets quite upset. But it means that when you've made your little bubble, you don't want it to collapse. So it needs a little bit of thinking about it. And then the process is, you've got to plan the flight, get the equipment ready, and typically they do several different flights, you see. And then blow another bubble, switch it, blow another bubble. So you could make a series of bubbles. And, well, I'm sure some of you know more than me, but researchers, you can then quickly learn, how it depends on temperature, how it depends on the speed at which you blow, how fast you should cool it. There are all sorts of different details. You want to characterize the bubbles. See how can you alter the thickness of the film, to make it thin or thick. The viscosity in relation to temperature, the speed of cooling, and all sorts of technical, metallurgical matters. These are just engineering questions, how to do all this. And then metal foams. And then, of course, move on from gallium to the sort of metals which we really use in practice. Aluminium. These are 2 famous aluminium alloys used in the aerospace industry. So use those. They melt at about 1,000 degrees. So then this is a further step forward in the equipment you need at 1,000 degree temperature and so on. But it's a very step-by-step process. So this seems to me a very interesting, potentially interesting research topic. So that's a recommendation from the viewpoint that space travel is going to get cheaper, more and more activities are going to become possible. So this seems a promising direction. Other uses of microgravity, of course, are not just doing experiments, but making educational materials. And this, of course, has been done to some extent, taking video of interesting physical phenomena, experiments and so on, and just entertaining videos. There are all sorts of entertaining things one can do in zero gravity that are just interesting for children to watch, or even for adults to watch. So that there's other uses. As an educator, I often think, anything that stimulates young children to think, oh, that's interesting, I'd like to do that. That alone is very valuable, quite apart from actually technically whether the research is creating new ideas on it. And another, I talk about zero-G flights. They're just becoming popular as a tourism service. You may recognize this person. You know, recognize Stephen Hawking, a famous physicist. His body is kind of partly paralyzed. And he took a flight in a parabolic flight in an airplane. And he said it was such fun, he will certainly go on a suborbital flight when it's possible. It's quite expensive still, but he plans to do that. And as I'll talk next, we're expecting that space tourism as a whole, traveling to space and back, is going to become as big as air travel, because just like air travel, it'll get cheaper and cheaper as it grows bigger and bigger, and more people will take flights. But from that point of view, from the entertainment point of view, even before these services begin, I'll come to them in a minute, the subject of space tourism is it's a very interesting theme. It's it's a nice idea, which many people find interesting. And so, oh, thanks very much. This one. Sorry, just it's an interesting idea for entertainment. And in Japan recently, with colleagues, we've got a comic story. And this is now on the web, actually. It was all in Japanese, but there's 140 pages of this comic on the web. And it's a comedy thriller based in the world of space hotels. So we jump to 20 years from now when there are space hotels everywhere. And many... And, well, I won't tell you the story because I don't have time now, but this is a theme which colleagues now in Malaysia are planning to make an animation out of. And this is a part of the preparation. As I put here, all innovation is very difficult. Raising the first investment is very difficult and requires a lot of preparation. This is a poster of the plan here. And this is some of the detail of the preparation for the animation itself, the story. A great team, some of whom are here in the room today. Anything new is difficult, and it's famous that investors never want to be the first investor, because they say, if it's such a good idea, why is nobody else investing? Why am I the first? So that it's difficult, but we're making steady progress, and one of the main people is here in the audience today. And also to back up this is me, I provide the, if you like, the technical thing. But what I foresee, and we've only just got it on the web in Japan, so it hasn't really got much momentum yet. This idea, and particularly being popular with young people, will help to spread the idea of space travel, which is an important part of the industry becoming a successful industry. So then I want to, thanks very much, talk about space travel and space tourism, so how it may go. My comparison to the air travel industry. Do you know the answer to this? How many people flew on aircraft in the year 2000? Yes? More than 1 billion people. But maybe even more surprising, do you know how many people flew in 2008? 2.5 billion people. It's growing so fast like this. We're already probably up by 3 billion. I mean, it's going to be 5 billion. It's over the top of you. It's an absolutely huge number. And if you think about the Wright brothers just 100 years ago, over 100 years ago, if you'd said to them, okay, how many people will fly on an airplane in the year 2000? They could never have guessed 1 billion. I think they wouldn't have guessed 1 million. I think they may have said. In the year 2100. I haven't got time today to discuss that in detail, but I'd be happy to discuss it. Why they couldn't. And we've worked out a scenario. We need to start travel to the moon in the 40s. So we think that suborbital travel will boom in the 20s, orbital travel will boom in the 30s, and then lunar travel will start in the 40s. And this will become, if you see that, the air travel industry is responsible for about 100 million jobs in the world. Directly and indirectly, because of all the hotels and restaurants which are made possible by air travel. See, without air travel, I wouldn't be here today. So space travel will do the same in the 21st century. And that's, for me, it's a wonderfully optimistic viewpoint. There's a lot of talk about running out of resources, resource wars, and troubles in the world, the environmental problems. No, I think this is a really very positive view of the future. So then I'll just really run through the sort of how I see the growth of the tourism industry over the space tourism industry over the next few decades, which I and colleagues in Japan are. The first rocket plane, German engineer Fritz Opel, a really interesting guy. He put rockets on all sorts of things. He put rockets on a bike, he put rockets on a car, he even put rockets on a train, and he put rockets on an airplane. So So they developed this rocket plane, which flew at 1,000 kilometers an hour. And that was done by joystick, you know, there was no computer control in those days. And the pilots were teenagers, you know, teenage pilots flying up to thing. And they built hundreds of these and flew them fighting. And also in 1942, in Japan now, on the it was an A4 rocket, it was called. The rocket flew to space and came back down again. They were developing it, you know, this was, again, fighting against London. But it was the first day they had a successful flight. You know, they had several failures. And then that day, and they had a party that evening. And the leader, General Dornberger, gave a speech. And he said, okay, today we showed that humans can travel in space. After the war, space travel. And they drank, you know, cheers, Prost, whatever they say in German. And here we are, 72 years later, we still haven't started space travel. So it's really kind of a tragedy, you know, after the German engineers really were visionary, you know, about the good idea of space travel. And well, you know the story, they were all captured afterwards and forced to make missiles, you know, for the next 50 years. So the suborbital flights, oh, well, I'll just go through. What happened afterwards? This was a British fighter plane with a rocket engine, designed by one of the German engineers, the one who designed the Messerschmitt ME-163. This flew, we need to get to 4,000 kilometers an hour to get to space on a suborbital flight. This was 2,800. And then in America, the X-15, it finally reached 7,000 kilometers per hour. And they flew to space several hundred or so times. This was for research purposes. But then the whole project was cancelled in 1968. So these were reusable piloted rocket planes, you know, going to space and back. And then, you probably know, in 2004, this little two-stage space plane developed in the States flew to space and back 3 times. And that was the first time in 36 years that a reusable piloted vehicle flew to space and back. You see, the advantage of a reusable vehicle is it's much cheaper. You know, you just put more fuel in and fly again. The space agencies use missiles, essentially, which go to space once, you know, so that they're very expensive. And Spaceship Two, this is the vehicle which is now being test flight today. The rocket on the upper right-hand side. You can soon find this on the web if you look for Spaceship Two. This is a picture of one of the test flights. And for various reasons, the design is not perhaps as good as it might be. So they were hoping to start flights in 2008, but they're still saying next year. They hope maybe to start this year, but this year or maybe next year. But the good thing is there are several other companies who are really ready to do the same thing. So on the left here is we've got a company called Xcor, this is 2-seater. And these are to do these suborbital flights. You just go up for a few minutes, they're going to take you back. What I should perhaps say is that this company, Virgin Galactic, who do this, they're very good at marketing, and they've got 600 customers who've paid $200,000 each, and they're just waiting for the series to start. And once the service starts, I think you'll see in the newspapers and the media a lot more attention given to space tourism. You know, journalists, they're interested in the subject, but they say there's no news. You know, we've heard people saying it's going to happen, but once it starts, it'll be a big change. And I should say that the designer of this vehicle says once they get into operation and build a whole lot of them and fly repeatedly, it will come down eventually to a few $1,000s per head. So that's something like 15,000 ringgits per head, which is a lot of money, but it's not like 200,000 USD. You know, so with these different vehicles, on the right here is a European proposal. It's not been funded yet, but these all essentially do the same thing. They carry a few people up to orbit and back again. And of course, they can be used for scientific research, and will make that much more cost-effective. So these are 2 other European proposals. And this is another one by a British company, British Crystal Space Planes, a very old friend and colleague, which developed the SR-53. And this is a very realistic proposal, but the guys are still trying to raise money. They've got a crowdfunding project on at the moment. And as I said, what they propose is that, and these are the engineers who do it, they say, once we build 50 and fly them every day, just like aircraft, it'll get really much cheaper. And so many people will be able to experience it. Another approach, of course, is a vertical takeoff, vertical landing. And this is a little rocket. It's only about 3 meters tall, but a reusable rocket which they built in Japan and flew a dozen times or so. Again, if you look up RVT, you can find videos on the web. And based on that, they're developing an unmanned rocket which will fly up to 100 kilometers and back again to do experiments. And based on that, the guys who are doing this, they're not allowed, they're not doing it. Carrying version, and that would look like this. Is Iron colleagues who we're not in the agency, so we're a little bit freer than them to make publicity. We call this Uchumaru rocket. And then this is just a few pictures I got an artist to do of what the service would be like. And you see, because it's reusable, then you do repeated test flights. And you know the safety of an airplane or a car or anything comes from repetition. You know, if you've used a vehicle 100,000 times, you know it's much safer than if you've only used it once. So that these will fly from airports, essentially, airports. If they're more dangerous than that, then no one will use them. They be doing our test flights. So this is like at an airport. And this is just a small one with seats for 5 or 6 people. Here's we call him a space conductor, the guy who's like a cabin attendant and with some customers. And then this is literally only 5 minutes from the ground up to space and back down again. If you use a winged vehicle, of course, you can fly around like an airplane for half an hour or so. But still, once you fire the rocket, it's 5 minutes back to the ground. You know, it's unfortunate it's so short, but the travel companies say, don't worry about that. We know the travel service will be a few days of training and preparation and so on to make it an attractive service. This is another friend. He works for Nissan. He's a designer there who did some graphics for us. And while it's firing, of course, you're pressed down in your seats. And this is the horizontal, vertical takeoff. On the wall here, we've got a meter saying it's 2.5 G. And then once the engine's cut off, of course, you can guess what happens. You float about inside. And this is where the travel companies offer various services. You take videos and things. And of course, zero gravity, up and down. There's no up or down, so you can look at it whichever way you like. And then the other thing in market research, what people say they want is to look at the Earth, the view of the Earth. And this is, the Earth is very close. When you're 100 or 200 kilometers up, the Earth is still very close. It's not a long way away. So it's a very dramatic view, very close to the window, as it were. So looking out the window and seeing the Earth will be a very popular part. And then landing, and then maintenance at the airport, just like the aviation. Space travel is the extension of air travel, because it's the same business model. So in America, the regulations for space travel are being done by the FAA, the Federal Aviation Administration, and I think that will be the same in every country. This is a newspaper article we had about our work a few years ago, which says, it says, can we have space travel for 50 man yen? It's 500,000 yen, which means about 5,000 USD. And that's the journalists were saying, if it's that price, everybody will go. And this is just one of the examples of what we're doing. Tokyo is on the right here, and here in Shizuoka, there's a little airport here, which is the nearest airport outside Tokyo, because we think those services won't fly from Haneda or Narita because they're much too busy. And so the local government gave us a little budget to have this is a photo of the airport. It was just after it's been developed. It's quite a new one. This is when the grass has grown a bit. But we had this event there. They paid the Space Tourism Society in Japan to have an event discussing building a spaceport at the airport there. And we had a panel discussion, and our treasurer was this person. Do you know this person? Anyone here a Gundam fan? No, the Gundam animation. This is Mr. Tomino. Tomino, the god of Gundam. Gundam is a very, very popular animation about space in Japan. It's been running for 30 years, and it still sells $100 million a year USD of plastic models. And he's very keen on space tourism. So our little society, we only have about 15 members, but we have some very good senior guys. This is the main reusable rocket designer at the Space Agency in Japan, Professor Yatani. This is Professor Takano, who's the chief antenna designer for the solar power satellites, which I'll talk about later. And I gave a talk about it, and this is a local businessman. And oh, this is just an example. This was the local newspaper article about that event. And what they say here is this will really revive the local economy. And this is one of the, as an economist, I'm very interested, because in Japan there are nearly 100 little airports around the country, and they're nearly all in the red. And they're, how can we revive them and so on? So flying some suborbital flights would clearly be a very beneficial thing. And of course, Spaceport Malaysia, which is, nothing is finalized yet, but there are some very good plans moving forward, will, I'm sure, be just the same and have some very, very beneficial effects. And of course, it depends how much support the government gives and so on. But if you think that the space tourism industry is going to go like this, then having a spaceport, and it's a race. Having the first spaceport in Southeast Asia, you then become the hub spaceport, and all sorts of benefits could follow. So then, jump to orbital travel. You remember there's three phases, you see, where suborbital, I think, will become a very popular and interesting field in many ways, but the real target is to get to orbit. And the key thing about that is this thing that you need to get you have to travel 8 times faster. You need about 8 kilometers a second. And if you remember some basic physics, remember the kinetic energy is the square of the velocity. So to go up and down again is 1 kilometer per second. To go to orbit is 8 kilometers. So you need 8 times 8, that's 64 times as much energy. So 64 times as much fuel. So it's a much bigger vehicle with much bigger tanks. And the vehicle has to be much lighter to carry the fuel, but still be strong. It's quite a challenge for the vehicle designers. And then to make it reusable, you've then got to do the re-entry. But the re-entry is, you're traveling 8 kilometers a second. You've got to get to 0 to land. So you use the air resistance as you come into the atmosphere to slow you down. Well, when you're traveling 8 kilometers a second, the air resistance, you get very, very, very hot. You remember one of the space shuttles basically broke up because there was a hole in the wing and the hot air got inside and melted it. So suborbital, contrary-wise, is much easier. It's only 1/64th of the energy. So suborbital, when you re-enter, the amount of energy is much less. So there's no danger of melting. You get a little bit hot, but you can land, refuel, and so on. So anyway, going to orbit is a much bigger challenge. But designers are thinking about this, and they know how to do it. It's just they've never had a budget to do it. And this is a 5-seater, a 2-stage vehicle, where the upper stage would go up. And then here's a 50-seater, which would get the second phase and get. Quite low cost, you see. The Spaceship One, which went up to space, was $20 million, the whole thing. Well, $20 million is what NASA spends every morning before lunch. It spends $50 million a day. Even in Japan, the space agency spends $20 million every 3 days. So if space agencies said, okay, let's do this, I mean, it's just very, very, very easy for them to do so. That's why I'm sort of optimistic, and the penny's going to drop, and they're going to say, hey, let's do this, and then they'll open the whole space travel up to the public, and the thing will run more smoothly. Now, these are bigger projects. So a commercial version, so I should say this, Spaceship One only cost 20 million, but it only had to do 2 or 3 flights to win a competition. To make a commercial version where you can fly it over and over again, there's a few hundred million. But these ones, to go to orbit, they're billions. I'm talking billions. But then, a new aircraft like the 787 or something, this costs 7, 8, 9, 10 billion to develop. And then they build hundreds. You see. So, seen in that viewpoint, if suborbital is successful and they make money, then it will go into orbit, I think, almost automatically. It's a rather comic type picture, but of the Kankomaru, which is an orbital version of the vertical takeoff one, which I showed the suborbital Uchumaru. And there's an organization called the Japanese Rocket Society, which did a sort of 10-year study on this in the 90s, and basically did a lot of work on it and showed how realistic it was and that it could be done. It would need billions of dollars to start. And the result was, well, let's start with a suborbital project, and if that works, then go ahead. So these are pictures of the facilities you need to launch and take off, and this is fitting it into a hangar and so on. And this is an interesting picture. This is from 1998. Ivan Becky was a very senior manager at NASA on the said these are billions of $8 billion. That is a lot of money. But NASA spends $18 billion every year. This would be a 10-year project, split between a few countries, Europe, Japan, America type of thing. It's like a new Airbus or a new Boeing, So it's an absolutely feasible type of cost. So although nowhere yet has made any commitment to doing this yet, I'm quite confident that orbital vehicles are going to happen once suborbital is seen to be successful. And then, once you're going to go to orbit, you don't want to just go up and come down again. You want to stay there for a few days. So, space hotels. And you say, space hotels, this seems very futuristic. But of course, actually, we've had space hotels or space stations for a very long time already, since the 70s. And they're easier to build than the launch vehicle. Because remember, the launch vehicle, it's got to carry all this fuel up to orbit and then come back and up again and down again. That's the key vehicle. But the space hotel, you launch it once and then it just stays in orbit. I mean, there's various things you have to do to maintain it, but it's not so difficult. So the first ones will just be made of modules. And these are pictures from the 60s and 70s. It's actually quite fun for children. You give them a module shape and say, how do you want to make your house? Which way around will you put the bedroom? Where will you put the windows and stuff? It's quite fun. This was in the 1980s. One of the reasons I first visited Japan in 1990 was to visit the people at Shimizu Corporation, because they published this design of a space hotel. So I went to see them and never went back to England after that. And then this is a German design. And this was interesting, talking to the designers here. They said Europe has developed a module for the space station. The International Space Station has American, Russian, European, and Japanese modules. And they said, we've built it. It cost about $2 billion to develop. They said, but as engineers, once you've developed it, you want to build 500 or 5,000. A new car, developing new cars, hundreds of millions of dollars, and then you make $1 million of it. So we said to the space station, the space agency, how many do you want? They said 2. One for orbit and one for the ground. So he said, we thought, how can we make lots of modules? What possible demand is there? And they said, there's only one, and that's for hotels. And we know lots of people would like to go to space if it could be cheap enough and safe enough. And so this is their design for a hotel. And you can see it's got lots of modules. And this is their more recent one, just a single module, what they call Space Hotel Berlin. You've got to start somewhere. The cheaper, if you can make it cheaper to start, then it's easier. And that's why these parabolic flights in aircraft are such a good place to start, because they're so much lower cost, even than suborbital. These are just, until recently, if you looked on the web, Google Images for Space Hotel, there was almost nothing there. And recently, there's quite a lot. It's quite fun just to look. And these big studies, just looking at that, you can tell how far away the Earth is. You see, this is about 5,000 kilometers. So this isn't a low orbit hotel. This is halfway to the moon. And here's another one. It's quite a nice place to visit, you have to agree. What's funny is all the hotel staff are robots. It makes it a bit lonely, but I suppose they're cheaper than keeping staff in the hotel. But you can see for an artist, it's quite an interesting concept. What would the view be from a space hotel? This upper one is actually from Finnair, the Finnish airline. If you look, it's got Finnair. This is their idea of a future Finnair space tourism trip. And the bottom right is just some crazy designer. In zero gravity, you can make things any shape you like. Real estate developer and hotel owner, quite a rich guy in the States, and this is under development. And they've recently made an agreement, as on the bottom here, to attach one of their modules to the space station. So this is kind of a sign that this is serious, it's not just a joke. And these are just some graphics by them about how they want to use their modules in the future. Bill Lotz. wobbling blob of water with air inside, and they're just floating about inside. Then the third guy, he's a bit rough, so he's burst the balloon. It doesn't really matter. They just say, okay, we'll try again. So use the hose to collect the water again and then do it again. And you see, in a room this size, you can do that with zero gravity. It would be really a unique kind of fun that everybody would want to do, and you'd never forget it having done it. So that's why I say, you know, everybody can fly today in a way that the Wright brothers could hardly believe. So that's why I think this is going to be just the same, you know, in future everybody will be able to do it. I think I've said in Japan recently, there's lots of planetariums in Japan, you know, all the school children go to a planetarium at some point. But as we are here, I say a suborbital flight will be 21st century planetarium. All school children, maybe 12 years old, will take a trip on a suborbital flight. You know? And in about 30 years, they'll take a trip to orbit. I mean, why not? That's what progress is. You know, things that were very difficult in the past become easier. And so then the space hotels, you know, it's not just one thing. They'll develop and develop, and one of them is building bigger and bigger rooms. You know, like these huge bubbles. You see, so if you make a thing like a stadium, you can have zero gravity football. Incredibly popular, but in zero gravity you have obviously different tactics you can do. See, so you can do all sorts of strange things like, this is more like, I guess, like rugby than football, isn't it? You can shoot your guy across the stadium to the side and fly. And we've got a little project working on this in Japan at the moment, that you can put on wings and you'd be able to fly around. You know, you need a big room in which to do it, but this surely has to be popular. And you can have races, you know, sprints, long distance, a kind of slalom, you know, like a skiing slalom. And then, how about a zero gravity ballet, you know, the kind of, or synchronized swimming, you know, it's very popular with women, isn't it? Women swimmers, you know, synchronized flying. In a big, this would be, you know, a room that's 100 meters across. And how about this? Now this isn't magic, this is just a little electric jet engine. There are battery-operated jet engines nowadays. You'd fill the handle with batteries, and you could fly about 50 kilometers an hour. We can't do it here, but you know what you could do there. I mean, everyone's going to want to do that, don't you think? Anyone who's read Harry Potter, which is most young people. And this whole thing is rotating slowly. This whole room is rotating slowly. And there's an acrylic wall, transparent wall in the front here. So water is held out by centrifugal force. So you can swim along on this surface. And then because you're in zero gravity, you can jump out of the water. You know, when we're swimming, a dolphin can jump out, but we can't, we're just not strong enough. But in zero gravity, we will be able to. And then sort of play with these huge blobs of water floating. It's kind of mind-boggling, but I certainly know I'd like to have a go if it's possible. And so that's the end of this first section. That's about 2/3 of the way through. So then just a few words about lunar travel. I won't talk about this in great detail because this is a little bit further still, you know. But as I said, I see suborbital really booming in the 20s, orbital booming in the 30s, and lunar travel starting, at least starting in the 40s. And suborbital will fall to a few $1,000s a head, so that's about, say, 15,000 ringgits a head. You know, in about 10, 15 years, say. And then orbital will fall. The price that the guys doing that thing, they think it'll come down to about 10, 20,000 US per head for a weekend in orbit. Okay? Well, that's what? That's 20,000. That's about 50,000 ringgits. Well, today that's a lot. But with economic growth, you know, another 20 years from now, average salaries will have risen very substantially. And it'll go on getting cheaper and cheaper. I'm a great fan of Air Asia. Because just recently, trips I live in Japan, from Japan to here, have gone half price. I mean, you know, I thought aviation was already mature, but no, another 50% reduction. So I just think you shouldn't say, oh, it'll never get that cheap. I think whenever you say, oh, it'll never be that cheap, I think that's probably a mistake. I think it'll go on getting cheaper and cheaper until the end of the century. And don't forget, you know, this happened ages ago. They walked on the moon ages and ages ago. It's just extraordinary that America stopped that. And didn't make lunar travel into a business. Oh, sorry, I jumped all the way. Sorry. This is an article you can see from 1998. You know, they discovered ice on the moon. They haven't actually gone and dug it up yet, but they think there's several billion tons of ice there. And at that time, it was quite interesting. Hilton said, oh, well, if there's ice there, that means there's water. We can have a pool, so we'll build a hotel there. And they didn't actually do it yet, but it's an idea that's been around for some time. And Bigelow, Mr. Bigelow, has plans to use his modules on the moon as well. This is a nice picture from 1987. Obayashi is one of the big Japanese construction companies of a tourist center on the moon. This is a glass dome, you see, glass dome made from lunar rock. You see, you can make glass there. And this is a view from inside there. You see, there's a park inside. And this building, they said, they wanted to build a building that, if you see it, you can say, you couldn't build that on the Earth. You remember the moon, the gravity on the moon is 1/6 of what it is on the Earth. So any structure you can build on the Earth, you can build 6 times taller on the moon. So this building, they said, you know, you can build that on the moon, but you couldn't build it on the Earth. And this, here's inside the dome. Here are some people flying. Because one of the things you can do on the moon, like in zero gravity, is you can fly. Because if you think of what your weight is and divide it by 6, that's about the weight of a big bird, the biggest birds. And this is a very rare picture by NASA from a few years ago, called the Lunar Games. You see, it's on the moon, and they built this stadium here. And it's kind of like a joke. You see, here are these hurdles. You see here. The hurdles are about 3 meters tall. And the diving board here is about 50 meters tall, because it's 6 times. And here's a guy doing pole vault, you see. I don't know, that pole must be about 40 meters long. And you probably can't see it, but just up here, there's some people flying with wings here. And this actually comes from a story, I don't know if you know this story, by Robert Heinlein, called The Menace from Earth. It's just a short story about some teenagers who live on the moon, and their hobby is flying in a great big sort of stadium they have there. It's an absolutely terrific story, written in the 50s. Heinlein was an engineer, very realistic and very, just a sweet story about flying. And I'm sure that flying will become a very, very popular kind of hobby. I think it'll become part of the culture there. You know what they call a dome city? You build a huge dome, maybe a kilometer across, and buildings maybe 500 stories high, because it's 1/6 gravity. So then, to go to work in the morning, you walk out onto the balcony, put on your wings, and just dive off, and fly to your living space. Or maybe you use a broomstick. I'm not sure, but I mean, when you use your imagination a bit, it will be a really interesting culture there. So that's why I think it'll just get so popular that people just build and build and build. And this is a picture of some American students designed the first Olympic stadium on the moon. I don't think it's gone anywhere, but I was interested to find that. It's company Golden Spike. Did you see? This is quite interesting. The managers of the Apollo project, who are now, they're in their 70s now, you know, they said, it's ridiculous, no one going to the moon. We know how to send people to the moon, we did it, you know. So they've set up a company, and they're offering a service to other countries to send people to the moon, because they say, we did it before, so we can do it again. I don't know if they're getting customers. It's Delta company planning to do mining on the moon. And this is quite interesting. The European Space Agency has been doing a study with some architects using 3D printers. You know, 3D printers are a major new technology. There are nano printers and food printers and all sorts, but they also print whole buildings nowadays. And so they think that might be a good way to build a base on the moon. This is just I think he's an artist using a 3D printer to make a sort of object out of sand. I mean, it's a technology that's going to have big implications. And NASA recently developed, they got a printer which they're going to use in orbit, specialized for making things in 3G, which will be very interesting, to make things in 3G that you couldn't make on the Earth. So this just brings us back to this graph here, why I think this is not unrealistic scenario for the 21st century. And if you just think of that, this of course creates numerous business opportunities of all sorts. And I've gone on a little bit already, but one of the things that's surprising then is that even though this business itself could be a huge, huge business, it may not be the biggest business in space, because this will reduce the cost of getting to space so much. All sorts of other activities will become possible as well. And so new orbital industries. And as I say, they may grow even more important than just space passenger travel. And this was what I did my PhD on at Imperial College in London in the late 70s and early 80s. This is an idea to collect solar energy in space and send the energy down to the ground as a microwave beam. This was proposed in the 60s by a solar engineer who said, solar panels are great, but they're very expensive, and even today, they're not a cheap way to make lots of electricity. But if you use them in space, you could, in principle, have non-stop electric power. And the Japanese government has a plan. It's part of their policy to develop a demonstration satellite, and I'm involved in that. That's one of the reasons why I stayed in Japan, having visited there, because people are working on this project. And so, as I say, with low-cost launch, when I did my PhD, the conclusion was very simple. Technically, it appears to be possible. The whole thing depends on the launch cost. If the launch cost is low, it would be great. If it's not low, then it's just too expensive. So if space tourism can reduce the cost, just like aviation reduces the costs, then these kind of projects become possible. And the energy industry is as big as the tourist industry, trillions of dollars a year. So this could become a huge business. And this is a very nice graphic by a Boeing engineer of what the orbital factory might look like for making these satellites. These are satellites, they're 10 kilometers long, 5 kilometers wide, with hundreds of square kilometers of solar panels, which is what you need if you want gigawatts of power. And made of very light aluminium frameworks. And well, that would probably nowadays be 3D printed. 3D printers hadn't been invented when this guy made his picture. But this, then you start realizing this is going to open up industrialization outside the Earth, outside the Earth's system, environmental system. This is a book, see, published 76, just when I was a student, called Lunar Utilization. And this was about building SPS, this is solar power satellites. If you're going to build a lot, like a few million tons of aluminium and silicon to make solar panels in orbit, then you wouldn't go on launching all that from the Earth. You'd get it from the moon or get it from asteroids because they're made of rock just like everywhere else. And this is a book full of interesting papers about that. Again, I thought this was going to happen when I was a student. It hasn't happened yet, but this is a picture of, see, here's the moon, and then you have a moon orbital base. You have a geostationary orbit with the satellites in, and then you have a manufacturing facility here. So there's been a lot of work done on it, including on the chemical processing of lunar rock to make aluminium and silicon. And that, of course, leads to a whole new world. You see, once you're starting using extraterrestrial materials, space materials, then this word resource wars, which is talking about running out of resources and so on, becomes ridiculous. The idea we're running out of resources is silly. There's so much in orbit, quite apart from the stuff on Earth. And the cost is trivial. The only cost to start is to get space travel going, which, as we've seen, there was an estimate of about $10 billion. $10 billion is 1% of what America's already spent in the Middle East in the last few years. They spent trillions. I mean, do you think even Britain spent hundreds of billions on these totally meaningless wars, And not just the moon, but asteroids and comets. There's lots of work on the materials they're made of and so on. And in Japan, again, quite coincidentally, I think, really, this satellite called Hayabusa, did you ever hear this? It went to an asteroid and collected some dust, just a few grams, and brought it back to the Earth successfully, and so they were able to analyze that. So that using asteroid materials is already, actual practical. And as of last year, 2 US companies have announced plans to start prospecting asteroids to find which ones have the best value materials. And of course, these are all just graphics today. These are nice graphics. But at least it's not science fiction anymore, because a satellite has already been sent to these things. And it depends on a business again. If there's a demand in orbit for hundreds of thousands of tons of aluminium and silicon, then people can say, hey, we can get it cheaper from the asteroid or cheaper from the moon than launching it from there. Which brings us back to resource wars. This is a book. The author is such a soul person. He's written another book about how the human race is going to end up fighting over the last resources of Earth. I mean, strangely, it's not so. A lot of people still think like that. And this is from a Japanese newspaper, but you probably know this map. Here's China. This is a map that China says this is all China's sea.
this could well cause trouble. You know, it's already causing trouble. All of the countries, including Malaysia around here, saying, well, we don't really agree that that's all China. You know, there's different viewpoints. This could turn nasty. You have to always remember there are weapons salesmen. You know? The weapons salesmen, they're always trying to cause trouble because they like to sell weapons. And this could easily, Japan, you know, quite apart from this, Japan has problems up here with Korea, China, and Russia over the islands. You know, it's always those sorts of things. But as soon as you think of, well, actually, there are unlimited resources in space. And we don't, it's not that we have to spend $1 trillion trying to get them now, but if we go in the direction of suborbital flight and then orbital flight, reducing the cost of getting to space, just automatically this becomes possible. So again, it sort of opens the future, a really optimistic vision. A lot of Japanese kids are quite depressed, you know, very high unemployment. A lot of people, there's this word wapu, which is short for working poor, which you can imagine means that people have a job, they're not unemployed, but their salaries are so low, they're miserable. You know? And there's a lot more of that is because it's, you know, the effect of the long recession. And they say, and then we're going to end up with a war with China, and how can we possibly win that? Or we'll be the battleground between America and China. You know, it's quite a lot of reasons to be gloomy if you're a young Japanese. But with this vision, I keep telling them, no, there's actually a really very bright future if we just make the effort to go in this direction. So the cost of developing space is simply far less than any possibility of resource wars. I mean, they're always hell anyway, but resource wars already cost a fortune. So this slogan, to space, not war. Space industry will use the same technology as the weapons makers, you know, aerospace and so on. But this is I got the artist to see that the missiles being used for war is the same as a rocket you use to go to space. You know, you just decide to use the space resources. You don't have to have wars. And so just a few examples here. One we've already talked about, the bubble, metal bubble engineering. Another one is space tethers, and this is a way, I won't describe in detail, but when a passenger goes to a space hotel, when they want to return to the Earth, they have to slow down to re-enter. So they usually burn, like rockets say, they use some fuel to slow down and then re-enter. But actually, if you use a cable, called a tether, and the tether connecting the two, as the tether lengthens, you move away from the space hotel, the tension gets higher and higher and higher and higher. And the center of mass stays in orbit. And when you finally cut the tether, the vehicle is now too low to stay in orbit, so it automatically starts to fall down to re-enter. And the hotel has moved to a slightly higher orbit. Well, even in orbit, a hotel gradually loses altitude because of the air resistance. There's a little bit of air still in space. So there's a free way of transferring momentum from the vehicle to the space station, the hotel. So this is a very promising. And this is known. You know the principle of a mass spectrometer, where you ionize some materials and then separate them according to their mass, ultra pure. Well, this is the idea. What they say is you build a mass spectrometer 1 kilometer across. In orbit, you could have it's very high vacuum and zero gravity. And so you can, any kind of rubbish or anything, you can separate into the isotopes. With very high purity. So these are just some of the ideas of the industries that will arise once we have a lot of activity in orbit. And so from the economic point of view, you know, we have the world economy suffering from lack of new industries. That's what I tell the students, that the key thing is we need new industries. A lot of the old industries are now so efficient that they don't employ many people. And so this new industry could create employment for a lot of people. And the basic idea, of course, is very popular with young people. And this is just a graph of the number of American students who studied physics, PhD, in the 60s. And it collapsed here. And this was because the Apollo project was stopped. Through the 1960s, a lot of young Americans thought, if I work in, do things like physics, I'll be able to get to space. And once the Apollo project was cancelled, and you remember it was cancelled because the Vietnam War was so expensive. Well, why bother to study physics anymore? And I'm quite sure that once space tourism gets underway and people can see, okay, there's a project now to build vehicles to get to orbit, there'll just be a terrific boom in all of the subjects related to doing that. And so just to last few words, I've gone on a bit long, really for the younger people in the audience, how can you get to work in the space travel industry? There aren't any jobs there yet, but if you want to prepare for it, we use this word in Japan, supekon, which is short for space conductor, which is what we use for people who work maybe in a space hotel or in the sort of cabin attendant in the launch vehicles. And it'll start with suborbital, but of course it's really aimed at the orbital. And there's certain things you have to learn, and one of them is orbital plane. You know, the satellites stay in the same orbital plane. So if you want to get to a certain hotel, you have to take off at the time when on the Earth you go through that orbital plane. This is just some of the concepts you need to learn. Of course, like a cabin attendant, the spacecraft systems, so the air conditioning, safety procedures and so on. You'll need to learn a bit about propulsion, why rocket propulsion is different from airplane. And it doesn't use air, it carries its own oxidizer. How a rocket engine works. There's 50 different types of rocket engine. Learn some of them. Star fields, if you're trying to tell people where you are in space. Do you know this star field? It's Cygnus. Deneb was one of the giant stars. You know, it's 1 million times bigger than our sun. And we're gradually developing a series of tests, you know, so people can get a qualification as a space conductor. And one of the questions would be, what is the star directly above your head now? Does anyone here know that? If you were good at amateur astronomy, you'd know that. You'd be able to work it out. You know, tonight Orion's coming up from here, so it must be. I don't know, but that'd be a good test, wouldn't it, to see if you know the star fields. And the other good one is trampolining. Now, if you're going to work in a space hotel, it's no good if you bump into the guests. You've got to be very smooth moving around in zero gravity, and you can do that trampolining, 2 or 3 seconds. So some trampoline training, I think, will be part of the thing, and you have to show that you can move precisely with trampoline. So finally, in the meantime, until the business is available, if you work in any of these businesses, I think you'd be in a good position to get a job in the space travel industry, the airline industry, airport, because airports will become, some of them become spaceports, you see, work in spaceport, hotel. A space hotel will be very like a hotel, but it'll also be like a cruise liner, because a cruise liner, all the staff stay on board with the customers and so on. Travel companies, building management. You know, a modern building, what they call intelligent buildings, a lot of technical systems which you need to understand, safety and so on. It'll be quite like a space hotel. Event management, you know, the media is going to be involved in a lot of this. And sports, I think zero gravity sports will become quite popular. You say, when will be the first zero gravity Olympics? What year? I haven't really made up my mind, but I would hope in the 30s. I would hope the first will be the 30s. Well, sports science, you know, it's quite a big business. You know, it's quite the physiology of flying. You know, which muscles should you train? Yes, and so on. So there's a whole lot of things I think which you can seriously do. This is quite apart from all the engineering aspects. You know, manufacturing components and stuff for aircraft and components. So good luck. I hope you can get a good job. And any questions?
What are the possible risks that you might face in space, and what do you think of the ways to mitigate them? I'm talking about already being in space.
Right. I mentioned just now that the regulations in the States are being done by the FAA. And the FAA has a aeromedical research institute. And the head of it is a guy called Melchior Antonano. A very, very nice guy. Very keen on space tourism. And he says there are 3 risks, different from flying on an aeroplane. And one is a major one. In zero gravity, the blood flow in your body is slightly different from on the ground. You know, on the ground, the blood pressure in my feet is high and then my head is low. And in zero gravity, blood comes up from your feet and goes to your head. The astronauts call it bird legs and moon face. Your face goes round and your legs go thick. And that's no difficulty, except there are 2 groups of people for whom that might be slightly dangerous. And one is people with heart disease, just because the blood flow is different. And the other one is some people who are taking medication for the head, for example, epileptics. Because if the blood pressure changes, the medicine you're taking the effect may be different. So he says these should be okay, but a person should check with the doctor beforehand. The other one is radiation. But for a suborbital flight of a few minutes, then there's really no danger at all. For a few days in a hotel, or even a few days on the lunar surface, the radiation you'd get is about equivalent to what you get in a year on the ground here. You know, because we're getting radiation all the time from space, but in small amounts. As you go higher up, you get more. You know, even the pilots and stewardesses who fly from here to Europe, they go quite near the North Pole. You know, the Earth's magnetic field is this shape. Here, the radiation doesn't really come in, but on the top, it comes in, and they get quite a big dose. On a, I mean, not like dangerous or something, but they say that they have to measure it to be sure that they're not going above a certain level. And of course, the other main one is just the reliability of the vehicles. And that's just aviation, you know, just flying repeatedly and checking everything and keeping it.
What about threats? Flying meteors?
Debris, space debris.
Space
Yes.
debris, yeah.
This recent film, was it called Gravity? Was it? Yeah. I think he's trying to scare people. My friend, some of my friends. It's funny. Some of my friends said that really made me want to do space tourism, and other people said that really made me not want to do space tourism. There is debris in space, and what's interesting, it's got to be cleared up, and we know how to clear it up. There are two main types. One is great big pieces like satellites, and I think the best proposal for that is they say just introduce a salvage law in space. Do you know the law of salvage? It's a very old law, been for hundreds of years. If there's a ship or an oil rig or anything floating uncontrolled in the sea, if you take over it, it's yours. Legally, it's yours. But if it then crashes into somebody else, then it's your responsibility. But they say, okay, make anything floating in space that's no longer under control. Anyone who wants to collect it can have it. They think that once this kind of business starts to go and there's a lot of activity in orbit, then people will collect it because it's valuable. So it's certainly like a space junkyard kind of business. But the other ones are the little things, you know, about a centimetre across. There's lots of bits of plastic. There's even screwdrivers and gloves, things floating in orbit. The danger is that what they call hypervelocity impact, you see, they're traveling at 10 kilometers a second. If even a chip, you know, like a couple of millimeters across, hits something like this, it shatters into pieces. So the plan is, and there's an Australian team working on this actually at the moment, is you'd use a laser to slow them down. And if here's the Earth, you've got these kind of things coming around here, you have a laser faced horizontally, and with modern radar and what they call LiDAR, which is laser radar, you can pick up these pieces, you can see where they are. And if you hit them, you need a kind of military type laser. You know, the German engineers developed a laser recently, which they got a steel block a kilometre away and they cut it in half with the laser. So these lasers are seriously powerful. But the altitude is typically a few hundred kilometres. So the little piece of debris, you hit it on the front where it's moving, the direction in which it's moving. And the outer surface, the whole thing doesn't melt, but the outer surface blows off like a little gas charge, you know, which slows it down, you see, the pulse. And so because it slows down, it starts to spiral into the atmosphere where it re-enters. So debris will be cleared up. The thing is that there's no demand to clear it up, you see. The only real, I mean, there are several hundred satellites in operation, but they don't get hit very much. It's, you know, there isn't that much debris. But it certainly will have to be. The good thing is, you know, that hotel companies, there are, you know, big hotel companies now, tens of billions of dollars a year. And once they've got customers going, they say, you know, you've got to clear up this debris, and it'll just be done quite quickly. I'll just say one thing about, oh no, I'll leave it there.
About the solar panels in space.
Right.
How do they transmit the energy to the space, down to the Earth?
Microwave.
I'm sorry?
Microwaves, so radio waves, yeah. What's interesting is back in the 60s they did experiments with this where they get an antenna delivering about a kilowatt of power and then collecting it with another antenna and turning it back to electricity. And powerful antennas today, for example at an airport where you have the long-range radar, they say these are giving off several kilowatts of microwave energy. You shouldn't go in front of that because it's the same as a microwave oven. It would cook you just straight away. Or if you throw up some like wire wool in front of it, it just would vaporize, they say. So these are already the technology for high power microwave beams is well established. I'm not sure how soon that will become a commercial project or not, but Japan has essentially no natural energy resources at the moment. Well, they've got underground thermal because they've got these volcanoes, but it's rather difficult to use that. So they're quite keen to build these and export energy to other countries. It's certainly a promising way of using solar energy, but the current project is to build a little one, just a few kilowatts, and then put that in orbit and then measure it as it goes over antennas on the ground to measure it. And I've got colleagues here in Malaysia and in Indonesia who are, in principle, going to join that project, and as the satellite goes over, we'll measure it to check that if it's working as they think.
Okay. I'm Kamal. I like your first slide regarding the air, cold air, and hot air, and make like a bubble.
Oh, the bubble, the metal bubble.
So that one's actually, I don't know what kind of the mechanism to create a microgravity inside the bubble, right? You need to.
What we thought of first is this is to be done in an aircraft.
Oh.
Sorry. On a parabolic flight.
I see.
So you've got 20 seconds.
It's not on the ground.
No. You can't get the microgravity on the ground.
I see.
Right. But you'd obviously developing the machine, you'd practice it. But to actually blow the bubble, let's say 10 centimeters across, you do that during the 20 seconds you get in the aircraft. So the aircraft dives, pulls up, cuts the engine, and then for 20 seconds inside you're just floating. And so you have to design it so that during that 20 seconds it pushes the metal out, pumps the air inside it, and then blows the air to cool it. But 20 seconds should be enough, shouldn't it? I mean, in principle.
Okay.
If you want to help design that, keep in contact, because what we're doing is we're looking for people who are interested to do this. It requires, kind of university type design.
But that one is almost more than 100 kilometers above the surface, right?
No. For an aeroplane, this is just ordinary aeroplane altitude, a few kilometers altitude. There's now a commercial service doing this in America. There's, in America, Japan, Europe, the space agencies have aircraft which they use for this. They need a special license because it kind of stresses the wings quite seriously. But it's a regular activity now. Do you know that film Apollo 13?
Yeah.
Remember, there's some scenes in Zero Gravity where they float about. Those scenes are all filmed in an aircraft doing that in episodes of 20 seconds at a time. So they've got in a 747, well, it's not a 747, but it'd be a room about half the size of this room. So you build your film set and set up cameras. Then as the airplane does this, you get 20 seconds, and so they say, okay, shoot, and then they have it go down like this. So it's all done in 20-second episodes. But they have to fly in a place where other aircraft aren't passing, but it doesn't have to go to particularly high altitude. It's just an ordinary flight.
That's it. How is it? I mean, like nobody really do this, because I'm like you. I'm from the financial side. So how about the cost that you need to do this? I mean, like to have that in your mind.
Well, the cost is like chartering a jet airplane. So in Japan, they just have a little business jet. I think in Europe they use an Airbus. A big Airbus. Well, I don't know what a charter flight is. You're talking tens of thousands of dollars, actually, probably for a single. And they do what they call a campaign. So they assemble a bunch of people who are going to fly on it, and then they do about 10 or 20 of these parabolas. In the States, this company called Zero G, you can soon find them on the web. I think they charge about $4,000 a head for a person, just as a sort of tourist. And there's a bit of training beforehand. It's partly fun, and partly work kind of thing. And take photos together, all standing on each other's head or something like that.
Yeah. I think it's good for Angkasa as well, to generate income from this and then to do more research on other stuff, like we are talking about the solar and everything.
Yeah. Perhaps you'd like to say?
Just to give our response. Actually, we do have the facility. We have done how many times? 3, 4? How many microgravity
in Japan?
In Japan?
Since 2008.
Since 2008, we are requesting for participation from universities, so they can propose any of their microgravity program. Of course, it's judged by the Japan and our people, and whoever won, we will send them, and they carry out in Japan.
So next my turn.
So that's what we have, unfortunately.
Since they have a ISS up there now, why don't they have such starting industries to do this type of structures, so that by doing this, they can, kick off a bigger space stations and lighter space stations. I think some industries are looking forward for this. This is a much a lighter steel means lighter vehicles means more economic. I think, is there any plan to do this? Another question is that, is there any other ways to go to orbit without using combustion?
Not yet.
Because when I was a little child, there's an experiment of having what you call it, these balls, and then you can have a lift.
Yeah.
Because you have a lift to the
space elevator.
Is there any research on this?
I'll answer the first question first. Of course, for the space station, they continue looking for things to do there, useful experiments. But I'm afraid it's really just paralyzed by the cost. It's so expensive to get there. You see, the only way to get there now is to use the the Russian rocket, the Soyuz. Each flight is about 100 million. So anything you do there, you've got to think, well, maybe 3 people going up, 1/3, you're talking 30 million flights. So even for a company, it's like having a laboratory. Just to open the door costs $30 million. It's a seriously expensive thing, you see. So once it's 30,000, then of course all sorts of things happen, the new possibilities. And likewise production, you see, even if you invent something, to produce it costs so much. So it's just a vicious circle of cost, I think, is the main problem now. I mean, for example, as I said, I read about these metal bubble and all the fantastic possibilities when I was a student. People have been thinking about it, but unless they get it cheap enough, it just doesn't make any sense. So that's why the recent kind of revolution inside NASA, as I say, it's still a civil war. There's still a bunch saying, no, NASA should do it. And others saying, no, it's got to be done more cheaply. But I think we're on the way now. If Virgin can start their services soon, it'll really, because, as you say, businesses are looking for opportunities. And if it's so popular, well, let's get in. But the other one about how to get to space all that, getting to space cheaply. Space elevator, there's a group called the Space Elevator Society, and there's a Japanese Space Elevator Society, of which I recently was involved in an event of theirs. Do people know this idea? If you build an elevator, you know that here's the Earth. Low orbit is just here, It goes around in an hour and a half. If you go out to orbit here, this orbit takes 24 hours. Okay? It's 36,000 kilometers. So here's the Earth. It's 3 diameters away here. And that's where the satellites are, which take photos of the weather. So they're always hovering over the same point. So they say, okay, if you went here and you lower a rope from there to the ground, okay, you could climb up the rope, or use it as an elevator, just use some electricity to get to orbit. And it's true in principle, but it depends on the materials, because if you use steel rope, as the rope gets longer and longer and longer, it gets heavier and heavier and heavier and eventually breaks. So they say, okay, you make the rope like this, it's thick at the top, or it has to be strong, go down. And that's fine, but with steel, a rope, cable, 36,000 kilometers long, it has to weigh about 1 trillion tons. But just recently, just last year, the Japanese Solar Power Satellite Research Society, in our annual meeting, we had 3 guys from the Elevator Society that came along. When I say professors and all sorts of people. And they said carbon nanotubes change everything. Carbon nanotubes, it's perfect chains of carbon atoms. They're so strong, you could make a cable this thick all the way from orbit down to the ground. So they're saying, any day now, in just 20 years. The only trouble is, you need a cable 50,000 kilometers long. And do you know how long the longest carbon nanotube is today? It's a few millimeters. A few millimeters. Well, they say millimeters is fantastic. Do you know how many millions of atoms perfectly aligned? Still, from a few millimeters to a few tens of thousands of kilometers is a big step there. And there's a very interesting point there, which this Professor Inatani, who's the head of the reusable rockets, he said, when they get carbon nanotubes, long enough to make a good composite material, he said, we'll be able to get to orbit much cheaper, because the key thing for these vehicles is strong, lightweight materials. Carbon nanotubes is number 1, or it's going to be, or they think. So even though the elevator people say, now we can build elevators, the rocket people will be able to go even cheaper. than them. One final point, I've got a friend who's a orbital expert for NASA. He works out all the orbits of these kind of satellites and things. And he said the trouble about elevators, you've got this Earth here now, you've got an elevator out to high altitude. But satellites are going around the Earth, and there's lots and lots and lots and lots of satellites, you know. That you can't design them so that they'll never bump into the lower part. Here's the Earth, here's the elevator. I mean, out here it's okay probably, but if something hits it, you remember this is 10 kilometers a second. So then they're trying to think of, okay, you have an elevator with cables like this, you know, so if a satellite's going to bump into it, you pull the cable out. So some of the elevator people to me say to me, we'll just have to get rid of all satellites. So I don't think that's going to go. I don't think that would work. But then they say, well, maybe an elevator would be used on the moon, perhaps. But I don't know. It's a bit difficult to foresee elevators together with satellites. That's true. So that, but the good thing about elevators is you use just electricity, just like an elevator. Having said that, it's a very long elevator. 36,000 kilometers in an elevator. It's about a week inside. I mean, obviously they'll build elevators like ships. But, you know, far future, you could build a dozen elevators.
From what I know is that, I mean, the carbon nanotube is strong enough because the tensile stress is in gigapascal. Yeah, in gigapascal. That's why it's strong enough to withstand. But one of the problems is that you need a counterweight at the top of the...
Beyond, that's right.
Yes,
that's right.
You need a counterweight. And another problem is that the thermal stress that it will have to endure. So...
Heating and cooling.
Yeah, I mean, repeatedly heating, cooling, and maybe things like this. I mean, in terms of tensile stress, for example, by the wind, that's not really a big problem. Yeah. I mean, the Japs have been working on this, and their calculations show that, well, it's more than enough for cabin nanotube to use, CNT to use. But I think now they are working on the thermal stress to see if it works. And another thing is, of course, the counterweights.
Yeah. My orbital friend said, you can design some orbits of the satellite where it crosses the equator. It only crosses in certain places, so it would avoid it.
Yeah.
But you couldn't design it that all of the satellites came.
Yes,
And he
yes.
said, and then you have mistakes. You know?
And at
you have debris.
And at the end of the day, you still have the weight and then the lowering orbit of the satellite and everything. So there's some considerations in between, but in terms of calculations, it works.
It works, yeah. The other one, of course, is just electric launch. You have a thing like a sort of linear motor. You build the track of 50 kilometers long and you accelerate along it. And you can send something out of the atmosphere, but they say the best thing is something like a telephone pole, just long, shaped like a rocket. A box with people in would probably be, as you come off the top of the runway, you're going at high speed through the atmosphere, you see, so you get very hot.
Any more questions? Okay, one last question.
As the space stories and is all business-related potential, how about nuclear-based propulsion system to be used for the spacecraft that will take the tourists to be related in the industry? Because I know back in the 60s and 70s, the US military has tested the NERVA project, that is a nuclear engine for rocket vehicle application, and that engine, the Kiwi, the rotary disc nuclear propulsion engine, kind of successful until the environmentalists start to see nuclear as a very dangerous threat for all the things on Earth, and even in space, they also does not recommend such thing to be implanted. But we know now the nuclear is generating a lot of potential in recyclable energy and potential chemical impulse as well. So how we going to implement this kind of propulsion system for space tourism future?
I think you're right. I think nuclear propulsion could well be used in future. I suspect it won't be used for launch from the ground. People probably heard of nuclear rocket. The point about it, as you know, is a nuclear power station is it uses nuclear reaction to heat up water to drive the turbine. And the rocket, you want to heat up the fuel which you fire out the back. So nuclear is potentially very beneficial because you don't need much uranium. You create a lot of heat to heat your gas stove to fire in the back. The problem is, as I say, if you have an accident and the thing drops on the ground and spread nuclear uranium everywhere, no one likes that. So it became, as you say, environmentally, I think it's impossible to use it inside the atmosphere. But as I was saying, if you think of a scenario where we're going to have lunar travel becomes a big business, I would have thought from Earth orbit to the moon could well become nuclear rockets might well be what you'd use.
Because I see the potential because
No,
the oil is finite. That's why I see the potential is there.
A nuclear engine is not enough to go beyond the escape.
Yes, I know the
may
chemical
not be
impulse is not the action, but I want to just recombine the system.
The other one, of course, you know, is traveling to Mars. Personally, I don't particularly want to go to Mars. I'd like to walk on the moon, but you know this project in America to send some people to Mars one way? Did you see that?
Yeah.
Public thing. 68,000 people applied to go to Mars one way. You know, never come back. You die there. And so, for going to Mars, you know, this takes about a year in an ordinary way. But if you use a nuclear rocket, you can accelerate. You know, so certainly, see, the good thing about lunar tourism is you can get there, even in the Apollo project, it only took 3 days to get there. So you go to orbit, take 3 days to get to the moon, have a week on the surface, do some flying and things, and a week, 3 days back. So a 2-week trip, you know, it's very, very realistic. But to go to Mars and back is 2 years, you know. So even if you're very rich, 2 years is not serious tourism. But if you use a nuclear rocket where you're accelerating all the way there, then decelerate as well, you can, I believe you can cut the trip to at least a few months or something. So I would have thought in the further future, maybe second half of the century, it may well have become an important technology. Yeah.
Thank you for the very interesting and futuristic talk, Prof. And thank you for the questions and comments. Now, I welcome Dr. Nordin Ahmad to deliver a token of appreciation to Dr. Prof. Collins for sharing his experience and knowledge.
Show the camera.
Before I end the session, on behalf of Angkasa, I would like to invite all of you to join us for a light refreshment at the foyer downstairs. Once again, I would like to thank you for your participation and see you all again for the next Angkasa talk.
Kau ikut ke dia? Yang
We need more tops and